the first part of exponential equations that we're going to do is I need to kind of piggyback on yesterday's lesson with the growth models, and then we'll get into really the solving. So, yeah, this is the title. Yeah, I know y'all like the title of the section above it. So this section is entitled Solving Exponential Equations, but I'm going to skip to the back of the section, and I'm going to do that, and then I'm going to come back to the front with the solving, okay? So what we're going to talk about first is what we call compound interest. Well, actually, it's a little bit better than that.
Oh,
Noah.
better.
It's actually where compound interest is. Let's say you take $500 to the bank, okay? And this is a very, very like non-realistic example, but just to give you the idea of compound interest. Let's say the first year you make $10 in interest on your $500. So you have now $510 in the bank, right? That's right. Yes.
Why is
Okay.
that unrealistic? Because they don't.
First of all, nobody's going to give you $10 for having $500 in an account.
That's like what?
Unless you're in like the stock market or something and makes money, but just a savings account, nah. Okay, so let's say that happens, right? The next year when they calculate interest, assuming you don't have any deposits or withdrawals, it's just that $510. Do you make interest on $510 or do you make it on your initial $500 only? $510. So if you think about it, you're making money on the money that they paid you, so it's interest on interest, right? That's what compound interest is. Does that make sense?
Yeah. We need $10.
Because you
Interest.
put money in their bank.
You put money in the bank, they pay you an interest rate. And the thing is, whenever they recalculate, then they'll recalculate it based on your total amount, including the interest they already paid you. So it's to your benefit. You what?
Oh my gosh, I'm rich. I never take money out.
Your parents are rich. But
Okay, so like you might make, like, that's why I said it was unrealistic.
Because they don't get 5%.
You might get 10 cents for a year. I mean, it's not much at all. Yeah. Yeah, technically, when you put your money in the bank, you're loaning it to the bank.
Come on, Meg.
I know how money works.
We have it on video now.
Yeah, but,
All right.
But if you don't move your money, then you don't move your money around, then they like charge you. But then they charge you $5.
And that's why.
This equation looks quite different than the regular growth equation that you're used to, the growth model. And this takes into account the compounding of the interest. So your new variable in here is what? N. And so what?
They don't want.
We're assuming, no, they don't cancel. We're assuming that our time is in years. That's a 1, yes. We're assuming that our time is in years. So what N represents is the number of times that your money, that your interest is compounded per year. So yes, if I was doing annually, if I said that each year you got 5%, then yes, that would be 1. But most of the time it's going to be something like compounded quarterly, in which case N would be what? 4. What if it was compounded, excuse me, monthly? 12.
No, if it's like biannual, would that be just still 1?
2.
2.
Biannually would be twice a year.
Now, what if it's every other year? Would it be half?
Yes.
Bi-weekly, bi-monthly.
Well, they don't.
They could.
Yeah.
There's 2 separate words.
That's an N, yeah.
Bi-monthly could be twice a month.
All right, listen, y'all are getting into these arguments,
One,
semantics again.
1 is 1 in 1 month.
How about weekly?
What?
52.
52.
7?
Are still your rate. How about daily?
365 and a quarter.
Yeah, but yeah, you got the weekly.
And a quarter.
Oh my
How do they do
goodness.
those things?
Okay, listen, we're just gonna stay here in basic land.
No, you said daily, Meg said 1.
Okay,
I'm watching this video.
take
now.
your $500. 52. Take your $500 and walk down the road to Safe.
They don't do 5%.
And they say that they're going to pay you 2.5% interest. And they will compound it
Yearly.
Yeah, every 90 years.
weekly. How much money do you have in your account after 10 years?
You're gonna tell them.
Not much.
You plug in 12 for Wait, what is the
A is 500 because
It's the
that's your
rate.
initial amount. These are the same. It's the exact same formula as yesterday. The only difference is the N plugged in there, so they mean the same thing. So 500, I've got 1 plus, what's my R? 0.025 divided by, how many times is it being compounded? 52 times in a year times my 10 years. So the hardest part about this is not the plugging in part, but it's the how do I put it in my calculator in the right order part.
Where
Okay.
did you get 10?
I said how much do you have after 10 years?
So can't you do 2 times 10 first and then do it?
Sure.
Okay.
And have it to the 520, yeah.
Did you divide those 0.25?
If you put, yes, so if you put this in your calculator all at one time, you'll need an extra set of parentheses here around that fraction and a set of parentheses here up top around the exponent. But you can do it separately, and if you do it separately, you'll need to do the 0.025 divided by 52 first.
But then you get a
It will. That's okay.
you get a thing that you can. Great.
64.
All right, 500. Watch how I put it in because you will mess this up on the test because you don't put it in correctly.
Yeah.
Plus
Your little
0.025 divided by 52, right? And I also need to close out the 1 plus part. I'm going to raise it to, and I'm going to open the parentheses again. Now, if you went ahead and multiply those and got 520, you don't need the extra parentheses. But some of the multiplication is not quite as easy. And now I can do it all at one time. How much do I have after 10 years?
$642.
That is a lot.
That's $100, man.
$141.97. Trust me, that's a lot for a bank.
And if we wonder about really
What was the cent?
97.
If we want, are you gonna like ask them to find out how much their people are, and you have to like subtract back on the other that? Wait, I don't.
All right, what don't you understand?
Over 10 years. And I'm free.
That's raised up to the exponent. As we compound more times per year and we get closer and closer to compounding an infinite number of times, that is called continuously compounded, and it is a whole different formula. Much easier though.
Are we going to have to...
So you have to read the problem to see, is it compounded continuously? Is it compounded a certain number of times per year? Okay. If it is compounded continuously, that formula changes and even the variables used change. P, hurt, yes. P is my initial amount. So that's my A, right? R is the same and T is the same. E, remember, is that irrational number that we've talked about E, right?
No.
Isn't it easier? It pops up on the calculator, I'm like, oh, this is good.
Okay, so E is an irrational number that I won't even get into the 1 plus 1 over. Okay, we'll just say it's an irrational number like pi, okay? And there is a button on your calculator that is E. And if you look, it is right above the division sign. 2.718, and it goes on and on forever and ever and ever. Because it's irrational.
E.
Okay?
So it's like another version of pi.
It's not another version of pi, but it's a number like pi in that it's irrational.
So when did they use it away for this?
You do, and we'll use it a lot whenever we get to logarithms in a couple sections and things like that.
Wait, so what is it?
On the calculator, we just have equals. Am I right?
The same, so put a 1 for E. Okay. We'll talk more about this. We'll come back to this whenever we get to E in a couple sections. Okay. Rate and time.
Can you write rational? It's 2 R's. Why is it E?
I thought you were mad.
Is it not 0?
You need like a dark one to shoot.
That's the technical definition for E. You don't have to know that, but Marshall's so eager to learn all this stuff about E. We will get to this. This is saying the limit as x approaches infinity, which means if you could plug infinity into this equation, it would give you the value of E.
But infinity's not.
But you don't have to know that yet. We're going to get to that in a couple sections. This,
Do I need that?
not yet. Just, we're going to stick a pin in that, and I'm going to talk about solving equations, okay? I promise you we will get back to that whenever we get to E and logs and everything else. Let's talk about solving the equations and inequalities. Now, tell me this. If 2 to the x equals 2 to the 5th, what do you know?
X is 5.
X is 5. What if 3 to the x plus 1 equals 3 to the 8th? What do you know?
X
Why?
So 7 plus 1, right?
So what you're telling me is these have to be equal to each other.
Wait.
Why?
But X could be
In order to solve.
Make a general statement.
X is 7 because X
No,
plus 1.
general.
I am
Even
tired.
more general.
So what?
More general about what you are doing here.
You're setting up.
In order for it to be x by itself, x is need to be.
Okay, you're getting there.
I hate you, Jim.
X is 0.
If the coefficient is
So
equal,
x
then
by
the
itself is
exponent
equal to
has to
something.
be.
Okay, but not coefficient. What's the other word for it?
Leading coefficient.
What is the 3 called?
It's
Leading coefficient.
When you have something raised to a power, what is the something called? The base. If the bases are the same, then the exponents must be the same, right? If they're set equal to each other and the bases are the same, then the exponents must also be the same. Does that make sense to you? So it's got to be the same. We're talking about just one term on each side, right? So you just came up with that on your own. That was very good. Very good. But what if my equation wasn't quite so obvious? In other words, what if I had something like this?
You would have to square, no, not square, you'd have to like keep it
Solve
or
this
equal.
X.
So you're thinking along the right lines.
Would it be to the 6th power?
Okay, so here's what I call this. I call this in McGee world base manipulation.
Just like
What I do with this, I know that in order to solve for my exponents, I need to get the bases to be the same, right? Because if the bases are the same, the exponents are the same. So what I do is I look at it and I say, is there any way, and here's the key, they have to have the same value. You can't change the value of them. But is there any way to rewrite them so that they have the same base?
But parentheses around it.
2 to the 4x.
2 to the 3rd x.
2 cubed.
I meant 8 to the
What's 2 cubed?
8.
So 2x equals 3.
Viola. Voila, sorry.
So you're telling me that that's the same thing as 8. Wait, now there's still a 3 out there, right? Because it was 8 to the 3rd.
I was so young.
Do you agree that these give you the same thing? They're the same number.
So it's
So now do you agree the values have not changed? I've just written it a different way. It's kind of like writing 6 as 5 plus 1 or 2 times 3, right? You're just right. It's the same value. You haven't changed it. It's just written a different way. Can you solve it for x now?
Yes, you can.
What if it's not?
Yeah, because you
going to be
Stop
proceeding
like
with Q.
much.
I love these. These are so much fun because you really, really, really have to. I do. You're right. It's what I do. Look at this
I
one.
really love this section. Oh my god, y'all, this section is my absolute favorite. 4.
Let me record you so it's on here in case anybody has the same question. All right, what if you multiplied both sides by? Here's the problem
No,
with
not
that.
both sides, just the one.
Well, you can't. Whatever you do to one side, you have to do to the other.
The solution is a word.
I'm glad that's in there.
Now it's minutes.
I was thinking like 8 words.
Can't you what? Is 8 cubed 512? So you could, but then how are you going to solve for x? Because you don't know logarithms yet.
She might.
Just
Yeah, you never know what Lizzie knows. She
All right, look, I just want to say this because somebody said this and I kind of ignored it in the beginning because I didn't want to go that route just yet. But somebody said raise both sides to the third, which you can do because as long as you do it to one side, you have to do it to the other, right? So I get 2 to the 3x equals 8. It's more work. You end up doing the same. But over here, I could do 2 to the third is 8.
What about for the 1?
Okay? I like base manipulation much better than that, but whatever floats your boat. My butt is sinking. Yeah. What if you do it to the 1/3? So 1/3, 1/3. Is that what you mean?
I'm doing the base negative.
You would have 2 to the 1/3 x equals 8. You would have to understand that 2 to the 1/3 is the third root of 2. And to get rid of the third root, you would have to cube. Yes. I wouldn't do that.
Well, I'm doing the negative.
All right, what happens what?
And the base is negative.
You can still work with it. I'll show you one. Let's do another.
Is it always going to be for the squares?
There'll always be some way you can manipulate them. You just might have to even manipulate both sides. I won't do that to you just yet. Let's do, so which one are you going to, and so a lot of students will want to come here and say, oh, well, 125 is 5 cubed. I'll just come to the left side and add an exponent of 3. But you can't do that because it's still got to have the value of 5 at the end of the day. So what I can do, because I do know that 5 cubed is 125, I can rewrite 125 as 5 cubed. Yep, so you have 5 cubed, and then you have x plus 2. So here's the deal. Whenever I have a power to a power, what do I do? You multiply, right?
You're bored.
So 3x plus.
What's it doing?
It's like turning off and on.
Flashing. It has to explode if you do that.
So here, whenever I multiply, I'm having to distribute. So I have 5x equals 3x plus 6. You're multiplying them.
No, it's 5 to the.
It's 5 to the 5x.
Wait.
So I drop the bases and I set the exponents equal.
Oh, no, you did that.
That could be.
Quickly, this could get very nasty because I could have quadratics in here, which takes me back to a couple chapters ago where I'd have to solve quadratics possibly by factoring, completing the square, solve quadratic formula, any of the above. But whenever I solve this, subtract 3x, I get 2x equals 6, and I divide by 2.
Are we gonna have quadratics in here?
Could possibly. Yes.
So wait, so if you do that, you can just drop the bases
how it
until
works.
exponents equals
As long as your bases are.
As long as the bases are the same. Let's do one that's an inequality instead of an equation. Because it's the same, it's the exact same scenario. Let's say I have 16 to the 2x minus 3 is less than 8. What's 2/3? 8 is 2 to the 3rd. Is that going to help you with the 16? That's 4 to the 2nd?
Like, the second, like, that's what I
That
said.
would equal 2 to the.
And then parentheses to.
Okay, but they're not the same though. Your bases have to be the same.
2 to the 8th.
2 to the 4th.
Yeah. I can't do
I meant that.
So remember, the whole goal here is that you got it? Okay. The whole goal is that the bases are the same so that I can drop the bases and just work with the exponents because the variable's in the exponent. That's what I want to solve. So go ahead, Noah.
Is it now equal to?
So we keep the sign and we solve.
If there's a GCF, you can just divide on both sides.
Yeah. All right, so I could, you mean like here, could I divide by 4 on both sides?
No, that's what I did.
I'm gonna do like this just so that it's not some fractions that I have to work with.
You still get it right.
You do, but it's only at the end, it's the very last step here.
And that's like a reasonable answer.
Sure.
Oh, is it greater? What if it was negative?
If you multiply or divide by a negative number in an inequality, you have to flip that sign. What if?
Wait, don't we flip the sign?
Hmm?
If you divide the sign, don't you flip it?
If you're dividing by a negative number.
But you divide by positive.
If you divide by a positive, the sign stays the same.
And you have the sign is the same. I thought somebody said.
I won't work this one all the way out. Let's just see if we can figure out the base manipulation here. Is it still?
Yes.
Every time I look at it, it's not doing it.
We're honestly trying to see.
Just keep looking at it. It's like it goes off.
It's not when you touch your
I
computer.
think it's whenever you're like writing something. Yeah.
Yeah, look at the board.
And I think
With the board now.
I think your message depends on things like, why would you do it like that? Like, lean on it.
No, you're recording.
It's the HP line.
Y'all are crazy.
No, I'm.
Okay.
Oh, we're crazy.
Wait, how do you find that word?
So how do you, and I looked up, Noah was just going on his calculator as soon as I put it up there. So I'm assuming that you're looking to see 3 to what power is 243?
Well, I did the, 2 root of 243.
Okay.
But, like, they're decimals.
So here's what I would do. That's what I would do. I'd say 3 to the 3rd is 27. 3 to the 4th is 81. 3 to the 5th is, oh, there it is.
So why can't, okay.
Okay, but wait, it's not 243, it's 1 over 243. Y'all are so smart. So it'd be 3 to the 2x minus 1 and 3 to the negative 5. And then I could set those exponents.
And then,
You want me to finish solving it? I'll finish solving
You
it.
didn't give us a quadratic.
I don't think you're going to have any quadratics. I think I told a story.
if we do,
You don't. I'm looking, you don't just yet. You don't just yet.
but if we do, we have a single quadratic, that's 300 negative.
No, Marshall.